Hi guys, this is your first lecture on Trig. We're going to call this Trig section 1.1. We will end up going through chapter 5, 6, and 7 in your book, but I've reorganized those chapters. I don't love the way they're laid out, and so I'm just labeling these with my own labels. If you want to find and reference what we're doing in the book, you just look up the topic in the index and it will tell you where it is. There is reference material available. It's just going to be scattered throughout chapter 5, 6, and 7. So let's get started. This is our Trig section 1.1. Some of you have already had Trig. This might be a review, but many people haven't, so we're going to start at the beginning. The first thing that we want to do in a Trig course is start talking about triangles. So we do right triangles first, and right triangles are identified because they have a right angle in them, and that square identifies a right triangle. Okay, we can also have what's called, this is a right triangle. We can also have what we call an acute triangle. Now sometimes triangles are right triangles and acute triangles. That happens. But that's not necessarily always true. This is an example of an acute triangle. And they are identified because all angles, this is my signal or symbol for angles. It's a little like that's my angle, and then this is a little arc in it. Okay, so that's going to mean angles is going forward. All the angles are less than 90 degrees. That's what makes a triangle acute. And then the last one that I want you to be able to identify is an obtuse triangle. And that is identified because it has one angle that is bigger than 90 degrees. Okay? So those are our three main types of triangles. For the first part of this trig section that we're gonna do for the rest of the semester, we're gonna only look at right triangles. So in doing that, we have a couple functions to define. The first one is the sine of x. The sine of x, we'll look at the cosine of x. We're going to look at the tangent of x. And then we're also going to look at the cosecant of x, the secant of x, and the cotangent of x. Now I'm going to write these out in English so you know how to say them. This is, let's see, let me write it over here. This is sine, that's how you say that. This is cosine. This is tangent. Okay, and then over here, I'm going to put some ratios here, so leave some space. This is cosecant. This is secant. And this is cotangent. So when we're talking in class, you know what we're talking about. Those are the abbreviations. And these functions are defined based on a right triangle. So let's draw this triangle. We're going to call this angle right here theta. A lot of times we use Greek letters to represent angles. And the way that you label these sides is that the side across from the right angle is always called the hypotenuse. The side across from the angle that we are talking about or is labeled is called the opposite. And the third side is called the adjacent because it's adjacent to that angle. Okay? Once you label a triangle, we can define these trig functions in terms of a ratio of sides. So the sine is the opposite side over the hypotenuse. So it's this side divided by this side. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over adjacent. Okay? The cosecant, secant, and cotangent I've laid out in this way because cosecant is related to sine. It's the reciprocal. So you just flip this over. It's the hypotenuse over the opposite. The secant is the opposite of the reciprocal of the cosine, so it's going to be hypotenuse over adjacent. And the cotangent is the reciprocal of the tangent, which is the adjacent over the opposite. Okay, and the way I remember how they go together is the S and the C always go together, and the S and the C go together. Tangent, cotangent, they both have tangent in the name, so that one's easy, but that's how I pair those up in my brain. Okay, you should memorize this. We will be using this for the rest of the semester, and it's important that you are real familiar with how these trig functions relate to the sides of a triangle. So your first set of homework problems is going to, I'll do an example here, give you a right triangle of some sort. Okay. That's supposed to be a right angle. It may not look like it, but it is. And let's say this side is 10 and this is 20 degrees, and I want you to find x. Okay, so the first thing that you do is you locate the angle that you have been given and you label the sides. So remember that the hypotenuse is always across from the right angle, so this is the hypotenuse. The opposite side is always opposite the angle labeled. So this is opposite, and the third one is the adjacent. And then you circle what you have and what you want. So I have a 20, I have an angle, and then I have the opposite side, and I want the adjacent side. And then you go up into your trig functions, and you find the trig function that uses the opposite and the adjacent, because that's what you have. And if you look back up here, that is right here, opposite and adjacent, and that is tangent. You could also use cotangent, but usually when we have options, we go with the ones on the left side, so sine, cosine, or tangent. And the way that you write your equation is you go tangent, because that's the one we picked, and this spot right here is always an angle. It will never be a side. So the angle in the picture that we're given goes right here. You always take a trig function of an angle, and then you set it equal to the ratio of sides. Tangent is opposite over adjacent, so this is going to be 10 over x. Now on your calculator, tangent of 20 is just a number. The way you do that is you are going to take tangent, which is this button, and you're going to go 20 and enter. Now, one thing that you need to do at the very beginning of this section, and you won't have to do it again, is make sure that your calculator is in degrees. The way that you do that is you go into this mode button, and when you hit the mode, you get a bunch of options, and the third line down says radians and degrees. You want to make sure that this is highlighted. You want to go over to it using your arrow buttons, and you want to hit enter on it and make sure you're in degrees. And that way when you hit tangent of 20, it knows that you are looking at degrees. Radians we'll talk about a little bit later in a different section. Okay, so if I go on my calculator and do that, I go tangent of 20, I get 0.36397 on up, okay? You do not want to round these in between, okay? You want to store that number, and we're going to use that full number through the problem. And then you just solve this like an algebra problem. We're going to multiply by x to get that out of the denominator. And then we've got x times 0.36. I'll round this to 364 just for writing's sake. And then you divide by this number. So my x value is going to be 10 divided by that unrounded number, and I get 27.47. Okay, and that's the length of this side right here. The problems vary just based on which sides are given and which angles are given. Okay. If the problem says in the directions to solve the triangle, what that means is find all sides and all angles. So in the above problem, we just found the adjacent side. If I said solve that triangle, I would also want you to find the hypotenuse. Okay, so let's take a look at how you would do that. I'm going to draw the same picture again, and this time I have 10 here and 20. That's still given. If you want to, you can fill this in. Now we know this is 27.47, and I want to find this value now, my third side. There's two ways to do that. The first is you can set up another trig function. So this time when I circle what I have and what I want, I have the 20, and you can choose the 10 or the 27. I'm going to use 10 just so I don't have to deal with rounding, and I want this side. So what I'm looking for now is the trig function that uses hypotenuse and opposite. And if I go up to my trig functions, I see that that is hypotenuse and opposite is right here. It's the sine function. So now I'm going to write my equation using sine. Sine, the angle always goes next. Sine of 20 is the opposite over hypotenuse. So this will be 10 over x. Okay, I'm going to multiply through by x. You can turn this sine 20 into a decimal if you want, or you can wait till the end. This time I'm going to wait till the end, just show you what that looks like. So the answer is going to be 10 over sine of 20. And then on my calculator, I'm just going to plug that in. 10 divided by the sine of 20, and I get 29.24. And that's my hypotenuse. Something that you should know from geometry is that the hypotenuse is always the longest side. So as I'm checking my answer to see if it makes sense, I see that this side is 10, this is 27, and then this side is 29. Yes, that is the longest side, the hypotenuse, and that's a good check to do. There's another way to do this problem. You don't have to set up a second trig function. You can use what we call the Pythagorean theorem. This is something that you want to memorize. If you haven't already, we will use it quite a bit this semester. And A, B, and C represent the lengths of the sides of a right triangle. So if I have a right triangle here, the A and the B can be either of the legs, but C is always the hypotenuse. So this is the side across from the right angle. This is the hypotenuse. C has to be this side. But A and B are interchangeable, and they can be either one of these, however you want to label it. And it gives you a way to calculate one of the legs if you have the other two. So in our previous example, let's say we had this triangle that was here. We had 10 and we had 27.47, and if I wanted to find the hypotenuse, instead of setting up this sine function, I could use the Pythagorean theorem. So this says that if I take 27.47 squared, and I should use that stored value, not the rounded number, plus 10 squared, that's going to give me my other side squared. So I go on my calculator and I type that in. And I get 854.86. And then I'm going to square root both sides. Square root on my calculator, I get 29.24. Okay, which is what we got doing it the other way as well. Now, if you round in the middle, you will be off. So you need to make sure that you're storing all decimals and using the whole decimal. So you can choose if you want to use trig functions or Pythagorean theorem on these problems, however you want to do it. If you want to find the measure of the third side, so let's take a look at this. Right here, I'm going to call this y on the triangle. That's a side that we haven't found. So if I say solve the triangle, I want to know the measures of all the angles too. Something that you should know for that, solve for y, is all the angles of any triangle add up to 180 degrees. So if I know two of my angles, I can find the third. I should have 20, that's my one angle that I was given, plus 90, that's my right angle, plus my unknown guy y should equal 180. So I do a little math and solve this equation, and I get 70. So that's my third angle. They all add up to 180. And that's how you solve a triangle. Some of your homework problems will just ask you to find one side, and some will say solve the whole triangle. Okay, and you can use Pythagorean and your trig functions interchangeably. Right. If you need more examples of those, there are some in the book. They are on the page for your homework. There's a page number and a worksheet. The page number will give you some examples. I can also do some more examples, and we'll practice in class on Tuesday. Next problem. I've got a right triangle, and this time my unknown is the angle, excuse me. And let's say I have this side is 10 and this side is 6. And I want to find x. So I'm going to approach this problem a similar way. I first have to label all my sides. So the side across from the right angle is the hypotenuse. The side across from the angle that's marked is called the opposite. And the third side is called the adjacent. I circle what I have and what I want. I want this angle. I have these two sides, and I find the trig function that is opposite and adjacent. Now if you look back up your formulas, that will be tangent. Now, after tangent is always the angle. The angle in this case is x, so my unknown is right there. And tangent is opposite over adjacent, so this is 10 over 6. Question is, how do we solve for x? We do not divide by tangent. Say that with me. You cannot divide by tangent. The tangent and the angle are locked. They are a locked box and they go together. There's no way to split them apart by division and multiplication alone. It's like log. We always had log of something. The tangent, sine, and cosine are like that as well. It's sine, cosine, tangent of something, of this angle. And the way you break the tangent off, because our goal is to solve for this x, so we do need to get rid of that tangent. It's the same way with the logs. We applied the inverse function. Well, the inverse function of tangent is inverse tangent. And that's the notation for it. It's tan to the -1. That means inverse. And whatever we do to the left, we have to do to the right. So I'm going to write this out one more time just so it's clear. So what we have is we're going to take the inverse tangent of our tangent x and then the inverse tangent of our 10 over 6. Now these guys will cancel, and that breaks that x off and lets that be alone. And the inverse tangent is a function on your calculator. It's right above the tangent. Let's scroll up to our calculator again and take a look at that. On the calculator, here's tangent, inverse tangent is right here above the tangent. So what you're going to do is second function and then hit your tangent button. So second function tangent of 10 over 6. And I get 59.04 degrees. Okay? So that's how you find an angle. You're going to use the inverse trig functions, and they're all above the inverse. Sine is above sine, inverse cosine is above cosine. Okay, last thing in this section is what we call special triangles. These are right triangles with specific angle measures that have a ratio of sides that's consistent, no matter how big or how small the sides are. So if this angle right here is 30 and this is a 60, then that makes that 90. This is what we call our 30, 60, 90 triangle. Creative name. And the ratio of the sides goes like this. If this side we're going to call B, then this side is going to be root 3 times B, and this is going to be 2 times B. And the sides of a 30, 60, 90 triangle are always in that ratio. So say, for example, let me show you what this means with numbers. Here's my 30, 60. And say this side is 10, okay? That's my B side. If we match these up, this is my B side. So that means that this side is going to be root 3 times 10. Root 3 times 10, okay? And this side is going to be 2 times 10. So I could say, all right, this side's 10, this is going to be 10 root 3, and this is going to be 20. It's a way of being able to find the other sides quickly just based on the ratio. Now, if I have a 30-60 triangle that this side is 40, then this side is 40 root 3, and this side is 2 times 40, which is 80. Okay, the idea, as long as this is still 30 and 60 in here. That's your one special triangle. And your second one is a 45, 45, 90. Whoop, 45. Okay, and its ratio of sides is, let me move this down a little bit. Got a little too close. If this side is, let's call it A, then this side is called A. It's an isosceles triangle, so those two sides are the same, and this hypotenuse is A root 2. Okay? So, for example, if you have a problem and this side is 10, then this side will also be 10, and this side will be 10 root 2. Okay? Now, here's what this creates for us. It creates a way to find sine, cosine, and tangent of a couple specific examples, so specific angles, exactly. So here's how we do this. What if we want to find the sine of 30 degrees? And I want an exact answer. I don't want you to do this on your calculator. I want you to do it using the special triangles. Actually, let's do this. Let's do sine of 60. That's a little more interesting. Okay, so we go up to our special triangle. Well, let me draw it again right here. Here's our 30, 60. This is our B side. This is our root 3 times B, and this is our 2B. And I'm looking at the 60-degree angle. So I'm going to circle that one, and I'm labeling my sides based on that angle. So that makes this the opposite side. Here's the right angle. So this is our hypotenuse, and this is our adjacent. Well, the sine of 60 is opposite over hypotenuse. So in how I've labeled these, the opposite side is root 3 times b, and the hypotenuse is 2b. The b's cancel out, and I get root 3 over 2. And that is the exact value for the sine of 60. Now, if you do sine of 60 on your calculator, you'll get 0.866025 and a couple more decimals. Okay, that's an approximation because it's a decimal, and sometimes we want an exact value, which is the advantage of doing it this way. But if on your calculator you do the square root of 3 and you divide it by 2, you will get that decimal. So you see that it's doing the same thing, it's just putting it in root form instead of decimal form. Okay, and in this way I can ask you what any trig function is of any of these three angles, 30, 60, 45. Let's take a look at, say, tangent of 45 degrees. So tangent is, draw our triangle. This is going to be A root 2. This is 45. Now in this case I can pick either angle to label, it doesn't matter because it's isosceles. So I'm going to go from here. This is my opposite side, this is my hypotenuse, and this is my adjacent. And tangent is opposite over adjacent. So my opposite is A, my adjacent is A, and the A's cancel and I'm left with 1. So tangent of 45 is 1. All right, so what your homework problems are going to look like in this section is they'll give you an expression, like, actually, they'll give you an equation of some sort. 5 tangent 45 minus root 3 cosine 30, and they'll ask you to find z. Some of them ask you to do this, some of them ask you to verify that the two sides are the same. You do them the same way. All they want you to do is crank out a number, an answer, and show that it equals the other side, or in this case, that's going to be your answer. So what they want you to do is, the 5 is just 5, okay, numbers are normal. The tangent of 45, well, we just found that up here, okay, that was this right here. So the tangent of 45 is 1. And then I'm going to subtract root 3, and I want to find the cosine of 30. Well, we haven't done that one yet, so let's do that. We're going to draw this triangle. Okay, and here's my 30, 60, and I want cosine of 30. So I'm going to go from here. This is hypotenuse, this is opposite, this is adjacent, and cosine is adjacent over hypotenuse. So that's going to be, oops, I didn't label my sides. This is b root 3, and this is 2b. So the adjacent side is b root 3, and the hypotenuse is 2b. The b's cancel, and I get root 3 over 2. Okay, so that's what's going to go in here. And then you just do a little math, crank this out. So this is going to be 5, and then the root 3, this is root 3 over 1. So I'm going to multiply those fractions. The root 3 times root 3 is just 3 over 2. And 5 minus 3 halves. I'm running out of room here. Let me move this down a little bit. 5 over 1 minus 3 over 2. Common denominator. And this is going to give me 7 over 2. And that's going to be my answer. Okay, so the expression, these are what the problems on the worksheet look like. They're just going to give you expressions. I want you to calculate a value and either find the value or verify that it equals the other side. Okay. All right, I think that's it for this section. So what I want you to do now is go back to the Canvas video place. There's a question to answer under the video. That's how you're going to get credit for watching this. Hit submit so that I can grade you. I know you've watched this. If you need to rewatch it, I would highly suggest watching this more than once. There's a lot of material, and make sure that you're comfortable with it. If you would like to, you can start on your homework for section Trig section 1.1. The worksheet that you're going to have is posted on Canvas in the new Trig section, and there's a book part 2. If you look on your pink sheet, they'll give you the numbers. If you would like to, you can wait to start the homework until we talk in class. Class is going to be open-ended for you to ask questions. You can either do homework questions or you can ask clarifying questions on the video, however you would like to use it. I will, after this, I'm going to post section 1.2 for Trig as well. We're covering 2 sections a day still, so you'll have at least 2 videos to watch for each day of lecture. So hope that was helpful. Give me an email or text message if you have questions.